Welcome to ClickMyProject.com. Now we are going to discuss about the project hybrid segmentation algorithm for medical image segmentation based on generating adversarial networks, mutual information and multi-scale information. Now we are going to discuss about the abstract of the process. In this modern globe, digital medical imaging processing is the major branch of studies in the field of medical and information technology. Every medical field relies on the digital medical imaging in diagnosis for most of their cases. One of the major component of medical image analysis is the medical image segmentations method, because the most crucial thing is the segmenting the portions of the affected portions. Medical image segmentations participates in the diagnosis process and it aids the process of other medical image components to increase the accuracy. In this process, we are going to use the algorithm named as the fuzzy C-means clustering. Is the most accurate method for image segmentation, and it can be smooth and be a desirable outcomes. Hence, the output of the segmentation is more fine and then more accurate for the segmenting the portions of the affected portions. Finally, the performance of the process is evaluated by means of the two parameters named as the accuracy and the error rate. So by using these two parameters, we can justify our process is efficient. Now we are going to discuss about the flow diagram of the process. This is the overall working flow of this project. This project consists the modules such as the input image pre-processing, image enhancement, segmentation, post-processing and performance estimation. These are the modules we have implemented in this project. At first, the input image is taken from the dataset. The dataset consists of a lot of images, medical images, which having in the form of images. After taking any one image from the dataset, the pre-processing will be carried out. In this pre-processing, we have the two stages of pre-processing. First stage is the image resize, then the second stage is the grayscale conversions. So for image resize, we are going to do the image resize in the size of 256 cross 256, which means the number of row and the column will be the 256. After doing the resizing the image, if the input image is the RGB image, it will be converted into one grayscale image, or else the image should be the same. RGB is the basic colors of the image, which is the red, green, blue. So after doing the grayscale conversion, the image enhancement is carried out by means of the CLA-HE method. So CLA-HE is carried out to enhance the pixel quality of the image. After doing the image enhancement, the segmentations will be carried out. So in this segmentation portions, we are going to hybrid the two algorithms named as the fuzzy C-means clustering and then the regional morphological. So MC-FCM and then the regional morphological. These two can be hybrid together to generate the segmentations algorithm. After doing the segmentations, the post-processing is carried out to importing the ground truth, as well as it will generate the segmented results. So both will be compared to generate the performance. Hence the performance parameters like accuracies, error rate, SSIM and dice coefficients will be evaluated. Now we are going to discuss about the running procedure of the process. At first, open the Matlab 2019B and then change the current directory. If you want to execute the process, just right click in the main file.m and select the option run. After the selection of the option run, the dataset will be open. In that dataset file, we have to open the lung images. Then we have to select the image from the dataset. After the selection of the image, the corresponding image will be processed one by one. Now the process will be done automatically. Once every process was done, the fuzzy C-means clustering asks the number of clusters. So here I am entering the number of clusters 1. So the final contour region will be developed for that particular region. Now we can see the results one by one. At first the input image is taken from the user side, so after the selection of the input image, those image will be looking like this. So after that we just move to the pre-processing. One of the pre-processing is image noise filtering. In case any other noises is present in the image, means we can't able to see that pixels, noisy pixels, so that reasons here we are applying the filtering technique to remove the noises present in the image. After the noise removal, we just move to the second stage of the pre-processing, that is the image resize. Here you can see the difference between the filtered image and then the resized image. Now the size of the image will be the optimum. After doing the image resize, the CLA-HE method is applied to estimate the pixel quality of the image. After doing that, the fuzzy Siemens clustering is applied to cluster the internal organs to estimate where the affected portion is there. So after doing the segmentations, then we are going to calculate the histograms of the image. So this is the chart for histogram of the input image. Then this is the chart for the histogram of LCM image. After that, this is the chart for the histogram of the CLA-HE method. After doing this one, the segmented clustered image should be like this: index 1, index 2, index 3 and index 4. The index 1 is the appropriate index, so we have entered the index 1 in the command window. Then the final segmented results will be looking like this. After doing this one, we are just making the contour region to identify where the affected portion it is. So the contour region will be developed like this. After doing this one, we are just having to estimate the parameters of the proposed and the existing for accuracy, sensitivity, specificity, precision, recall and dice coefficients. These are the values of the proposed method. Now those values are plotted in this message box like this. Thanks for watching this video.